Okay, guys, let's do a quick review of ionic bonds, and then we're also going to talk about covalent bonds today. So when we had an ionic bond, okay, remember it was between a metal and a non-metal, okay, and they transferred electrons. Also remember these were called compounds. Now, just a little side note, remember we transferred electrons and we made ions, which were charged particles. We had a cation, which was positively charged, and we had an anion, which was negatively charged, okay? And now remember, the reason that they become charged is because they are trying to seek that noble gas configuration, okay? So they're trying to get that 8, unless it's a helium or hydrogen, and then they're just trying to seek the 2, because remember, they only have one shell, one energy level. So super duper quick recap, because today, as you should have, hopefully, maybe, read about where covalent bonds. Okay, so if we have a covalent bond, okay, these occur between two non-metals. Okay, these are going to share electrons, and these are going to create molecules. Okay, so we're going to talk more in detail about these over the next couple of days, but this is just kind of a brief overview. Today, we're going to look at the structure they make to kind of keep it fairly simple. So now remember, guys, and the reason that they're sharing electrons is no different than the reason why ionic bonds gave and took electrons, and that's to reach that noble gas configuration. So that's to reach the 8. Now, as we progress through this, there are a few exceptions. So if you search on YouTube a video, there are some exceptions, and when we get to polarity, we'll talk about that. But right now, we're just getting the basic structural concept, okay? So let's look at hydrogen, and let's look at carbon. So let's say we had a carbon molecule. Now, a carbon molecule is a nonmetal. We want to remember, guys, and we made a special point about this, a hydrogen is still a nonmetal, even though it's over there on the far left. And we know it's over there in that first column because it has one valence electron. But it is still a nonmetal. So if I had carbon and hydrogen together, they would create a covalent bond, and I know that because it's two nonmetals. Okay. When we do our Lewis dot structure, we want to remember that our dots are representing our valence electrons. So carbon's going to have 4. But that should all be a review. Now, if I had a hydrogen again only has one valence electron. So remember, hydrogen's trying to reach 2 and carbon's trying to reach 8. Okay, what we're going to do in a covalent bond is these bonds, they're going to create a bond. These little guys are going to create a bond, and they are going to share this electron. And we're going to show that sharing by just a straight line. My line is not super straight, but there we go. Okay, by doing this, it's like a bridge. So now these guys are sharing these 2 electrons. So if we were to count hydrogen's electrons, they have his 1, but he also has access to carbon's 1. So that makes 2. If we were to recount carbons, we would have 1, 2, 3, 4, 5. Because remember, now he has access to hydrogens. Okay? But now this hydrogen's stable, but carbon is not. Because remember, carbon wants 8. He now has 5. So what are we going to do? We're going to add another hydrogen. And you can probably go ahead and predict how many hydrogens we're going to end up with in the end. But this hydrogen's going to share right here. So this hydrogen now has access to 2. And through this sharing, carbon now has access to 1, 2, 3, 4, 5, 6. So we're getting closer. Let me get rid of some of these little dots I just did. Sorry. Okay. So we're going to add an extra hydrogen. So it's going to share right here. And lastly, we need one more hydrogen. And by adding this one extra hydrogen, all of my hydrogens are stable. And if we were to recount my valence electrons for carbon, we've got 1, 2, 3, 4, 5, 6, 7, 8. So he has access to 8. So it's like they're sharing. We're not giving and taking like we were with ionic. Oh, sorry, a little too far. These little guys are sharing valence electrons. Okay, so this would be CH4 because we have 1 carbon and 4 hydrogens. Remember, 3 hydrogens wouldn't be enough. Okay, 2 hydrogens wouldn't be enough. We have to have 4 hydrogens so they all can get that octet. So they all can reach that noble gas configuration. Okay, so let's look at one more. Okay, so let's do PI3. This is called phosphorus triiodide. Okay, triiodide, and we'll talk about this tomorrow, but it's triiodide because it has 3 iodines. Okay, so the first thing that we're going to draw is our phosphorus. Okay, hold on, let me move that little guy over because I think that's not going to work well. Okay, so phosphorus, if we look at our periodic table, has 5 valence electrons. So 1, 2, 3, 4, 5. Okay, so guess how many he needs to make his 8? He needs 3. Well, guess where he's going to get these 3 from? I'm assuming you're guessing, right? Iodine. So we're going to draw my iodines. Now remember, iodine's a halogen, so it's set next to the last column. So it's a salt former, it's super reactive, and it only has 7 valence electrons. And because it only has 7 valence electrons, it only needs 1 more. So by sharing his 1 electron with phosphorus, this iodine now has 8, or has access to 8, right? And if we were to recount phosphorus, phosphorus has 1, 2, 3, 4, 5, 6. So we're getting closer. We're still not quite there, but I'm going to venture to guess, hopefully, maybe we've kind of assumed where we're going to get these other 2 from. So remember, we had 3 iodines. So we're going to put another 7 valence electrons. Okay, I'm going to draw this little guy. I'm not going to make him to where I'm just going to draw to the first one because otherwise it's going to be so confusing you're not going to see it. But if you see this, if we count our iodines, we've got 2, 1, 2, 3, 4, 5, 6, 7, 8. My dots aren't on, but that is 8. Oh gosh. I do. Okay, that is 8. Okay, which is what we want. And that gives my phosphorus now 1 additional 1. So he had 6, now he has 7. And so we are now only lacking that 1, and that 1 we will obtain from our final iodine. Okay, so very, very similar concept as to what we've already done. But again, this time we are not drawing arrows, we are drawing straight lines, and these straight lines are showing sharing of electrons. Okay, now we do have several elements that are considered diatomic. Now remember, we talked last week about monatomic, and that's when it's 1 single element. These atoms that are diatomic exist in 2s. So they only if they're all by themselves. So like hydrogen is 1. So you may see hydrogen like hydrochloric acid. And yes, I totally agree. There is only 1 hydrogen here. But understand, hydrogen is not all by itself here. What I mean is by that hydrogen can't be all by itself is that it can't just be hanging out all alone. Okay, hydrogen is diatomic. So di meaning 2. So if hydrogen is all by itself, it's going to automatically bond with another hydrogen. So it's always going to be in a 2. Now, if you look at the periodic table, there's actually a special placement on this. So if you look, this is, y'all know, I have awesome artistic abilities. But if you look on your periodic table, hydrogen, and the placement of these diatomic molecules, now you're not going to be allowed to write them on your periodic table. Okay. If you want to use your periodic table on your test, but it creates a 7 right here, but it also includes hydrogen. For me, because y'all know I've told you before, I don't do very well with straight memorization. I remember the placement on it. So it's going to be nitrogen, will always be an N2. It won't be all by itself. Oxygen, fluorine, chlorine, bromine, I'm running out of space, and iodine. and then of course hydrogen. So if you count it, we've got 1, 2, 3, 4, 5, 6, 7. So we have 7 diatomic molecules. Nicely, they make this 7 or Tetris piece on the actual periodic table. So just take a minute and look and see where it's located. It really does, I think, help you to remember, because as we pull into our next chapter, which might be in this unit depending on what happens school-wise, that's going to be really important. Okay. When you have diatomic molecules, sometimes, or even just molecules in general, sometimes we do multiple bonds. Okay. So if you were to do, let's see, let's make sure I'm not doing, I give you like most of these already. So for example, on your worksheet, I'm asking you to do today, I'm asking you to do nitrogen. Okay, and it's going to be N2. Now remember, nitrogen's diatomic, okay? So that means it's going to be 2, and nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. Okay? Remember, nitrogen wants 8, so he's short 3. Well, guess what? Both of these nitrogens are short 3. So we're going to share here. That means my nitrogens now have 6. I'm going to share here. That means both nitrogens now have 7. And I'm going to share here, which means now both nitrogens have 8. This will create my covalent bond. It's a triple bond. Why is it a triple bond? Because both nitrogens needed to seek that 8. So for your work today, besides the science notebook, I am asking you to do the covalent bonding sheet. It looks like this. If you look on Google Classroom, if you look on the daily objectives, it's linked. An image at least is linked. But just shoot me an email if you have any questions. It should be pretty self-explanatory. Remember, the magic number was 8, unless you're hydrogen, right? You don't really have to worry about helium with this because you know as well as I do, helium is a noble gas, which means it's non-reactive. So it's not going to want to or need to bond with anything. So yeah, so that hopefully that helps a little bit, guys. We will talk about naming stuff tomorrow and writing formulas. So please make sure you get this done. This is just the basic idea of it, as we will be building onto it in the next coming days. Okay? All right. Thank you, guys.